Hey everyone, and welcome back to the channel. In system design, our first instinct is often to make everything instant and synchronous. But the truth is, not every tasks need to be processed immediately, okay? In fact, forcing immediate execution can cripple your system. This is where message queue becomes indispensable. Knowing when to strategically use message queue is a hallmark of a great system designer and key differentiator in your system design interviews. Today we are diving into the specific scenarios where message queues are your best friend. Okay, so let's make a quick recap. A message queue is an asynchronous communication where producers will send a message to the main queue or the message broker, and we have consumers or workers that pull those messages from the message queue and work on them. So again, a message queue is a asynchronous communication pattern where producers send message representing tasks or events to a queue, and consumers pick them up later for processing. The message broker manages the queue, ensuring messages are stored reliably. It decouples the producer from the consumer in time. Okay, so what are the scenarios that you might use message queue in your systems and interviews? Okay, the first thing in asynchronous processing of long-running tasks. So let's try to understand the problem, the solution, and the benefits. So the problem, let's imagine a user uploads a large video of encoding or requests a complex financial report. If your web browser waits for these long operations to be completed, the user interface will be blocked, potentially leading to HTTP timeouts and frustrating user experience. The solution for this one, your application immediately sends a message like encode video or generate report to a message queue and returns an instant success response to the user, and a separate worker process, which is the consumer here, will picks this message from the message queue in the background and perform the long running task asynchronously. The benefit of this one, your application remains highly responsive, user gets immediate feedback, and you avoid blocking crucial web server resources. Number two, we have here decoupling services or loose coupling. So let's understand the problem. So let's say that in microservice architecture, if services directly call each other, they become tightly coupled. A change in one service might require change in the others. If a downstream service is slow or fails, it can block the upstream services. Okay. The solution for this one, we have a service communication via message queues via messages on a queue or via message queues. When service A completes the tasks, it publishes the message to the queue. Service B, C, and D may be subscribed to relevant messages from that message queue. Service A doesn't know or care about A, B, and C, and also A, B, and C doesn't know and care about A. The benefits from this one, independent development, deployment, and scaling of services, increased resilience because services don't directly depend on each other immediate availability. Number three, we have buffering and load leveling. So your system, let's understand the problem. Your system experiences sudden, unpredictable burst of traffic. Think of like a flash sale, a viral social media post, or a sudden influx of IoT sensor data. These spikes can easily overwhelm downstream services or databases, leading to crashes. The solution for this one, a message queue acts as a buffer. It absorbs these sudden bursts of messages. Consumers then pull those messages from the message at a steady, manageable rate that matches their processing capacity. The benefit from this one, we prevent downstream services overload, maintain system stability, and smooth out inconsistent workload, leading to more predictable performance. And next we have durability and reliability. So let's understand the problem first. If you make a direct API call to another service that service is temporarily down or crashes, your message and associated data or task might be quite lost. The solution for this one, message brokers are designed for durability. Messages are persistent on disk within the message queue until they are successfully processed and acknowledged by a consumer. If a consumer fails in mid-processing, the message can be re-queued and picked up by another consumer. And if it continues to fail, it might be sent to a dead letter queue, so to someone to look at this one. The benefit from this one guarantees message delivery, prevents data loss, and makes your overall system more resilient to transient failures. Lastly, we have cross-system communication and integration. Integrating a disparate system, especially those using different technologies or dealing with complex distributed transaction patterns, it can be challenging and prone to failure. The solution for this one, message queues act as a reliable bridge, ensuring messages are delivered by processed across the system, even if one system is temporarily offline. Across different systems, sorry. So the benefit from this one enables robust and loosely coupled integration between different parts of a large system or with external third party. Okay, so how to discuss this in your interview? So in a system design interview, it's not about always recommending a message queue. It's about accurately identifying the pain points it solves. When you are discussing a feature that involves long-running operations, communication between independent services, handling unpredictable traffic, or ensuring high reliability, that's your queue. To propose a message queue, okay? Clearly state why you are using it. For example, you will say like, I would use a message queue here to decouple the payment processing from the order for the order placement, ensuring the user gets an immediate response and the payment retries don't block the main order flow. So, in conclusion, message queues are fundamental to building scalable, resilient, and responsive distributed system. They empower you to manage complexity by decoupling components, smooth out traffic spikes, and guarantees message delivery. Mastering when to apply this powerful pattern is essential for designing robust modern architecture. So, thanks for watching and see you in future videos.